All right, welcome back to our fifth online lecture this semester for Biology 1217. Good to have all of you folks out there in the internet world. Want to pick up where we left off yesterday for those of you in class. We were talking about cartilage, and remember, we're talking about connective tissues, and I talked about fibrocartilage and how that it's not very vascular. Excuse me. So when there's damage to it, it doesn't tend to heal on its own. And with cartilage, there are three types of cartilage that we're going to take a look at during the course. And mentioned yesterday fibrocartilage. Excuse me. And fibrocartilage acts as a shock absorber for the body, as far as in the knee and in the intervertebral discs. Now, the other types of cartilage that we have in the human body, there is hyaline. And hyaline cartilage has a very similar matrix to fibrocartilage. However, it differs. And it is fairly firm. And what it does, it acts as a support and kind of a framework to different parts of the body. And what it does is it also resists compression. I'll give you some examples of where you find this. You find this in an embryonic skeleton. Now, if you think back for just a minute, when you were, I don't know, 2, 3, but when I'm talking embryonic, I'm talking obviously in utero. But even when you were born, you had a lot of hyaline cartilage in your skeleton. And I don't know if this ever happened to you, but if you were running away from your brother or whatever, playing it, and you ran into a wall or ran into something, you probably fell down and cried, but you didn't usually break because this hyaline cartilage has more flexibility than bone structure, and it tends to give some. The other areas where you find this is you find this at the ends of long bones. And in dealing with the end of a long bone, let's say here we have the femur again. Okay, here's the femur. Here's the tibia. Okay, at the end you have a small amount of cartilage. Now what happens is this cartilage over time, this will break down. And as that breaks down, that will set us into, break down. That will cause oftentimes some osteoarthritis where you get bone on bone and that's abrasive. But that's the cartilage there. And again, that tends to wear out as we age to some degree. You also have this as the costal cartilage between the ribs and the sternum. And it has a little bit of give to it. So, obviously, those of you who've learned CPR, you do your chest compressions. And when you do those chest compressions, that keeps the heart contracting or blood flowing through the heart to keep the person alive. So it does have a little bit of give in those areas. The other place that you have this is in your nose. And you've looked at the skeleton enough, you've seen that it doesn't have, it's got the two nasal bones up towards the bridge up here, but then what you see, this part is pretty much cartilage out here. Now it's pretty firm, has a little bit of flexibility, but not a lot. Now the reason I bring this up is this. You can take don't do this. You can't take your nose and flatten it against your face. If you do that, you're going to have some damage and it's going to be painful. And the reason I bring this up is that the last type of cartilage that we're going to deal with, the third type, is what's referred to as elastic cartilage. And the elastic cartilage, as its name denotes, is made up of, has a lot of elastic fibers in the matrix, in the chondroitin. And so it has a lot of elasticity, allows for a lot of flexibility. And where you have this primarily is in your external ear. And the external ear is the part that some of you adorn with rings and so forth. But it's out here. And you can take your ear, you can bend it, wad it up, let it go, and it springs back into its original shape. Very elastic. You can't do to your nose what you can do to your external ear. Elastic cartilage here, hyaline cartilage here. Hyaline is much stiffer, more supportive. The elastic is supportive, but it's got a lot of flexibility to it, okay? So that's the elastic cartilage. Now, as far as the other types of connective tissue, as we move on this morning, we're going to take a look at some of the other types here. And I want to go back to two other types here as we finish this up a little bit. One of those is bone. And let me get this centered here. Bone tissue. Bone has a very hard matrix. And again, I have Josh here in the studio. I'm going to call on Josh. Do you know, Josh, what are your bones primarily composed of? Do you know, Josh?
Calcium.
Calcium, exactly. So you've got calcium and also phosphorus, which are taken in by cells called osteoblasts. Osteoblasts are bone building cells, and what the osteoblasts do is they create what are referred to as hydroxyapatite crystals. And these hydroxyapatite crystals, that's what makes bone hard. And remember, though, going back with this, is that this is very vascular tissue. I've talked about this before. Bone heals much faster than tendons or ligaments do. And, you know, the purpose of bone is obviously to support the body and protect it. You know, your brain, which is one of the most vital structures in your body, is well protected by the skull. But also what happens within this is there's the process of hematopoiesis, which is blood formation. Blood cells are formed in bone marrow. And what happens with this tissue, and it's really kind of interesting tissue, I think bones are fascinating, is that osteoblasts are bone building cells. And what they will do is they will become what are referred to as osteocytes. And essentially what happens is they lay down all this calcium matrix, this hydroxyapatite crystals around them. Then they get embedded in the tissue and become an osteocyte. You also have cells called osteoclasts. And osteoclasts are bone cells which demineralize. I'm going to use that term. They demineralize the bone. In other words, what they do is they take out the calcium. So you've got these two types of cells, blasts which build, clasts which break down. And the reason that you have these osteoclasts is that you always have to maintain blood calcium levels. And we'll get to that later on when we talk about bone tissue more, when we do our skeletal system unit. But they have to maintain blood calcium levels because you need calcium in your blood at all times for muscle contractions and blood clotting. And it's important to maintain that. And if you're not drinking calcium, it has to come out of your bones. All right. Another connective tissue is blood. And blood consists of two major components, two major parts. Number one, there's what's referred to as plasma. And plasma is the liquid part that is yellow in color. Now, I'm trying to put Josh on the spot here, but Josh, what's the other yellow liquid produced by the body?
Not sure.
Okay. The other yellow colored liquid is urine. And your urine kind of imitates, to some degree, what's in your blood. But this is primarily made up of water and nutrients, things that you've eaten over the last day or so, antibodies, all of those things are in the plasma. Okay? Now, the second component to blood is what's referred to as the formed elements. And Josh, I'm going to go back to Josh here. Josh, you know what's these are the cellular component. Do you know what's one of the types of cells found in blood? Do you know? That's up here.
Oh,
How about cell type, like types of cells that you find in your bloodstream?
not sure.
Okay. There's the red blood cells. Red blood cells are also known as erythrocytes. Now I'm going to go back to Josh. Josh, you know what's the purpose of a red blood cell?
That is the carry speaking.
To transport gases. And Josh, you know what are the two major gases they transport? Do you know? Okay. One's oxygen and one's carbon dioxide. And do you know if blood's fully oxygenated, Josh, do you know what color it is? Red. And Josh, you know what the other color that blood comes in besides red?
Purple.
Not purple, unless you're a really rabid Vikings fan, and it's kind of the year to be a Vikings fan. But it's blue. So red or blue, and the red blood cells are what transport those gases. If you've got a lot of, if you notice, like for example, and I'll just show you here on the camera. Well, you can see that. My veins right here in my wrist. I don't know if you can see that very well. That blood's running blue, and it is in yours too. You can't maybe see it that well here, but I've got blue. Oh, you guys see that? Yep, got old skin there, getting up there in age. There's some blue blood running through my hand. That's because it's deoxygenated. Normally you have this oftentimes in veins. Most, not all, but most of the red blood is running through arteries, and that's deeper, okay? Now, you have red blood cells. Now, there's a couple other components to the formed elements. I'm going to switch pages here. And, Josh, you know, besides red blood cells, what other kind of cells do you have making up your...
Blood cells.
Exactly. White blood cells. Josh is a pretty smart guy. Leukocytes. And Josh, do you know what's the function of a white blood cell?
They're involved in the immune system.
Exactly. They're going to fight infection. And if you remember back not too long ago in class, I used this term, phagocytosis. That means cell eating. And they will go out and search and destroy, look for bacteria, and just eat them up. The white blood cells, they do a fantastic job of that. And then the last component of the formed elements are what are referred to as two different terms, thrombocytes. These are also called platelets. And the function of a thrombocyte or platelet is to clot blood. And if you remember the other day in class, I mentioned that one of the purposes of the thrombocyte is to connect skin when it's been broken so we don't continually bleed. And as it connects the skin together, it's considered a connective tissue. But those are the thrombocytes or platelets. And within the bloodstream, you have all these different components. White blood cells, thrombocytes, erythrocytes, or red blood cells, but a variety of different types of cells making up the blood in the human body. Now, the last couple of tissues I want to touch on as far as with connective tissues are these. And I'm going to go back to some of what we refer to as the connective tissue proper, types of connective tissue. And we're going to finish off with this and just talk about different classes of connective tissue. The last one's here. I forget what number I'm on, but I'm just going to write here adipose. Adipose is a type of connective tissue. Now, Josh, do you know what the term adipose is also in reference to? Okay. Sometimes people will use the term fat, okay, for adipose. And if you take a look, and I'm going to have you take a look at adipose here under the camera. Here's, this is out of your atlas. This is on page 6. But you notice it's got these large cells. There's the nucleus here, open area here where it's all white. That's where fat storage is. And the purpose of the adipose in our body, and let me just back up here. Adipose primarily consists of loose, or what's referred to as areolar connective tissue with Um, adipocytes. Adipocytes are another term for fat cells. And what they do is they contain large fat droplets. Okay? And so their purpose is to serve as energy storage. We all have varying amounts of what we term body fat. And it's to serve as energy storage. It insulates, keeps us warm, which we'll appreciate more in the next couple of months. And it also acts as protection. Your kidneys, as an example, are embedded in fat pads, and that helps protect them from trauma to some degree. Now, there's such a thing as kidney laceration, or from a kidney punch or something like that. That's why in boxing you don't let them punch too low. But that is there to protect. Now, what happens with this is this. Okay, you have these fat cells like this, and think of the white inside the green here as fat. If I overeat too many calories and so forth, what happens? Those fat cells will enlarge, but they will also divide. Remember, connective tissue is capable of division, and so I can get more cells and they get bigger when I get fatter. Now, if I lose some weight, let's say I get exercise and watch my diet, what can happen is these cells can shrink. Now, they'll still be there, but they shrink in size. So if I'm overeating, I'm going from left to right. If I'm watching my diet and losing weight, I'm going from right to left. So again, we're talking about the battle of the bulge, so to speak, and trying to protect our our health. But these are capable of increasing greatly in size, the adipose cells. All right, last few connective tissues. Okay, as we finish up. Let's do this, the reticular connective tissue. Remember, CT stands for connective tissue. And with the reticular connective tissue, this is basically forms a network of reticular fibers. That's what it consists of. And for the most part, this is what you find in a couple of different areas. One is you'll find this in your spleen and in your bone marrow. You'll find this in lymph nodes. And what the purpose of this tissue is to do is to form an internal skeleton, kind of an internal soft skeleton. Now, when I say skeleton, most of us think again of bone tissue. This is soft, and it just supports the cells within the tissue. Okay. And then the very last connective tissue that we will take a look at today, and then we'll move on to the integumentary system, is what's referred to as loose connective tissue, LOOSC. Sometimes it's also referred to as areolar connective tissue, loose or areolar. And what this consists of, I want to show you here in our diagram. This is in the atlas, this purple diagram, and you can see within it these black hash marks. They look like there's cells there. Those black cells, those are fibroblasts. We talked about those as far as making fibers. Then you have elastic fibers that kind of branch throughout this, and collagen fibers in it. And you also have some of these mast cells. Mast cells secrete histamine and heparin. And so it's kind of a compilation of a variety of things. It has within it elastic fibers and collagen fibers in a gel-like matrix. So it's kind of different because it's got two fiber types together, which you don't oftentimes find. It also has the fibroblasts and mast cells. Remember, the mast cells again secrete the histamine and the heparin that we talked about yesterday. Where you find this primarily is you find this making up the walls of capillaries, You also find it at the base of epithelial tissue. A lot of epithelial tissue has this. If you remember, at one point we talked a little bit about the kind of the basement membrane. A lot of times basement membrane has some of this in it. You also will find this around organs and in membranes. This helps make up a lot of the membranes in our bodies. Remember we talked about visceral pleura and parietal pleura. So a lot of the membranes that we've already looked at in lab consist of this type of tissue. Okay. So that pretty much wraps up the tissue part. Now with the time we have left, I wanted to get started on the connective tissues. Or not the connective tissues, the integumentary system, sorry. And so we're going to switch our focus for a little bit and go over to chapter 5. And I'm just going to title this on the top here, chapter 5. And we're looking at the integumentary system. And this is primarily made up of the skin, the hair on your body, your fingernails, toenails, sweat and oil glands. All of this makes up this system, all right? Now, I'm going to go back to Josh here for a second. Josh, do you know if you had a skin infection of some type, do you know what specialist would you go to at the Mayo Clinic to get treated?
A dermatologist.
Perfect. Dermatology. Now, I have to inform all of you out there in Biology 1217 land, Josh is not a A&P student, but he's actually very, very smart gentleman. So I'm glad to have him as my TV producer here. So thank you again, Josh. But dermatology is the specialty. And when we look, and I want to start out here, just some basic functions. And I'm going to go back to Josh. Josh, you know, what are some of the functions of this stuff? Protection. You know, intact skin is your first line of defense. And Josh, let me ask you this, protecting you from what? Exactly. Foreign particles, bacteria, and so forth. So it's protecting you from things like bacteria and viruses and so forth. You know, once you break the skin, then we got problems. Those of you who've been in sports at all, you know, when you get cut, like in a basketball game or a football game, they're supposed to, referee, if they see it, supposed to call a timeout, pull you out. You're supposed to get the bleeding stopped and bandaged up before you're allowed to go back in. But bacteria and viruses can't penetrate that barrier if it's intact skin. It also protects from dehydration. I don't know how many of you ever had a very severe sunburn, but when you burn badly, the skin comes off, peels back, and the new skin is oftentimes very it's soft, but it's also moist. But severely burned people oftentimes can suffer from pretty severe dehydration in that process of healing. A second major thing is that the skin is heavily involved with your ability to sense what's going on around you. It's got all sorts of nerve endings that pick up, you know, temperature, touch, pain, pressure. A lot of that is sensed through your skin. So very, very important function of the skin, all right? A couple other things I want to mention as far as purposes of the skin, or of this system. Temperature regulation. Now, I want to go through this a little bit and just kind of explain how this works, okay? And let's say it's, you know, another one of these beautiful, hot, 80-degree fall days, all right? Do you know, Josh, what does your skin do to help keep you cool? Okay? So if we're hot, we sweat, so the sweat glands will start secreting. Also, the blood vessels will tend to vasodilate. When they vasodilate, that means there's more blood going to the surface, and we turn kind of reddish. And that heat is convected out to the environment, and that helps us in cooling. When we're cold, later this week it's supposed to get fairly cold. not snow in the forecast yet, but when we're cold, what will happen is the blood vessels tend to vasoconstrict to some degree. And the other thing is that the hairs stand on end. We sometimes refer to that as goose bumps or goose flesh, but that creates a dead air space, and then that helps to keep us a little bit warmer. Okay. So, a couple other functions here with the skin. A fourth one is with your integumentary system. It's also involved in the synthesis of vitamin D. And to do that, you have to have sun exposure. You have to be exposed to some UV light to make that vitamin D and to synthesize that. Okay. Now, one last thing I just want to mention as far as functions. The body also does a limit of the skin, does a limited amount of excretion. And when I say excretion, we've already talked a little bit about sweat, but it also secretes sometimes some urea and some ammonia in sweat. And that's a way of getting rid of some nitrogenous waste that we necessarily don't want. Okay? And we also lose sodium chloride and water through our skin, okay, as we sweat. Now, going back here for a minute, and I want to take a look at this because we're going to talk in a fair amount of detail about the skin. If you have your book with you, if you flip to page 151, and I want to take a look at the structure of human skin as we continue on today, but we're going to take a look at the three different major layers that make up skin and then talk about these. And the two major layers, plus I'm going to talk a little bit about the hypodermis, which is not considered part of the skin, but we're going to talk about that anyway as we go. So I'm going to use the book here at this point in time. And if you look at page 151, here we go. Here's the key page. All right. And this is exactly what you have on page 151 of your book. You can see 151 up there. And what I want to point out is this. Do you notice how the top layer here, that's the epidermis. Then you've got a fairly thick, now this is obviously not drawn to scale, but dermis. And then the hypodermis down here. Now, we're going to kind of note this here as we go in just a moment, but the epidermis was made up of keratinized, stratified squamous epithelial tissue. It varies as far as how thick. Some areas you might have 5 or 6 layers of cells. Some other areas you might have 20 to 25. Depends on how much friction you get. You know, usually the thickest skin you have, thickest epidermis, is on the palms of your hands and the soles of your feet. And then you got the dermis here, and you notice in the dermis you've got blood. See the blood vessels in blue and red. You also have nerve endings here in yellow. You also have some erector pili muscles shown as muscle tissue there. And a lot of dense, irregular connective tissue. And then the hypodermis down below, you notice bigger vessels, arteries and veins, arterioles and venules, and a lot of adipose. You can see the yellow marbling down there. All right? And then, of course, also in the dermis, you have a variety of glands. Here's some of the glands here, those sebaceous glands. You might have sweat glands that are secreting up through a pore to the surface. But I want you to see this to start with, okay? And we're going to deal primarily with the time we have left today, dealing solely with the epidermis, and then we'll move on to the other layers, okay? And let's start out with this epidermis, though, to begin with today, all right? And let me see if we're centered here. There are 3 major layers to the skin. I'm going to include the hypodermis in this. Some authors don't do that. I am going to do that. And the first one is the epidermis. Now, I'm going to just talk in general terms here, and then we'll get into specifics here in just a minute. But the epidermis This is outermost, as you just saw on page 151 of the book. That's the one you see when you look in the mirror at yourself. And the epidermis is primarily made up of keratinized, stratified, squamous epithelial tissue. And that's the outermost layer. We'll come back and unpack that in just a minute. Second layer is the dermis. And the dermis is under, this lies under the epidermis. The prefix epi, E-P-I, refers to above. And like some of you maybe heard of the epicenter of an earthquake. That's somewhere you don't want to be. But that means you're right on the top, right underneath where the earthquake happened, and you're going to really be in a dangerous place there. But the dermis is under the epidermis, and this is primarily made up of dense, irregular connective tissue, blood, nerves, and so forth, okay? And then below that, 3, and let me, Josh, I'm going to ask you this question. Do you know what's the prefix that we use that means below? Okay. The last one is sometimes referred to as the hypodermis. This is also referred to as the subcutaneous layer. Now, hypodermis, hypo means below. I don't know if you've ever heard the term hypodermic needle, but when you have a hypodermic needle, you're putting it down in the hypodermis. That's what we call it, hypodermic. And the hypodermis has a lot of adipose, well, I shouldn't say a lot. It depends on who you are. I'm gaining more adipose as I've aged, unfortunately. I'm trying to lose some of that. But adipose and larger blood vessels. Also, there's some loose connective tissue down here, loose or areolar, okay, but that's the major makeup of the hypodermis. Now, with the epidermis, now I want to go back and we're going to spend some time with the epidermis, but these are the layers. Now, I'm going to have Josh flip back here for a second. The epidermis is avascular, no blood vessels. Here we have vascularity, we've got blood here, we got blood here. But in the epidermis, we do not have blood, all right? I don't know how many of you have ever done this before, but if you've ever gotten a letter in the mail and you went to open it and you got a small paper cut on your finger or thumb or something, and you didn't bleed. You just cut into it a little ways, like maybe, a 32nd of an inch, and there's no blood there. You're just in the epidermis. When you hit blood, you've reached the dermis, all right? Now, as we look at the epidermis, going back here, and we're going to take a look primarily with the time we have remaining in this video segment. We're going to look primarily at the epidermis, okay? And it varies in thickness. Now, Josh, let me ask you this. Do you know where is the thickest skin or epidermis on your body? Do you know?
Probably soles of the feet.
Exactly. And so you have a thick epidermis on the soles of the feet, okay? And I'm not going to show you my feet, but you all have seen your own feet, and they get calloused. The skin gets thick back on the calcaneus and up towards the proximal phalanx. But the soles of the feet, you have a thicker epidermis. You have also you have that thick epidermis on the palms of your hands, especially if you're involved in some kind of job where you grip things a lot, like let's say in factory work, if you do a lot of gardening, taking a hoe or a rake, you get thick skin built up. You get calluses built up. If you take a look, my hands aren't very calloused. I used to do a lot of weeding and stuff like that. But, the skin gets thicker where it's calloused. You have thin skin, or a thin epidermis, where you don't have so much contact. Like your eyelids. Eyelids don't have very thick epidermal tissue on them. Now, with the epidermis, there are a variety of different layers, and I want to talk about the layers and the cells. But let me do this. If you take a look, and let me have you flip to page 153, okay? Before I get to that, let me just mention, this tissue, again, is avascular. But it does come in different layers, or what we're going to use the term stratums. Layers or stratums. And if you look on page 153, I can't fit it very well underneath my TV screen. So I'm just going to note it here. But what you have is you got layers or stratums, and the innermost layer, first, we'll put this as A, is what's referred to, as the stratum basal layer. Stratum basal layer. This is the one that's in contact with the dermis, okay? And it's one row of highly mitotic cells. Now, I'm going to go back to Josh here. Josh, do you know what mitosis means?
Cell division.
Exactly, cell division. So this layer is living and dividing. It's a living and dividing layer. And within it, the cells are continually dividing. They almost look kind of cuboidal shaped. And within it, what you'll oftentimes do is there may be cells called melanocytes. Oops, let me redo that so I spell it correctly. Melanocytes may be in that layer. Now, a melanocyte is a cell that produces melanin. Okay, produces melanin. Josh, you know what melanin is?
It relates to the color.
Exactly. This is your primary skin pigment. All right, primary skin pigment. Now, I want to spend a little bit of time with this, okay? And as I go through this, I want to emphasize racism is just terrible. Because skin color of skin is just skin deep. I mean, it's incredible when you go into a cadaver lab. Once the skin is taken off the cadaver, you can't tell what color they were. But with melanin, do you know, Josh, what colors does melanin come in?
I'm not sure.
Okay. Comes in tan, red, black, brown, kind of a little bit of a yellow color, okay? But it comes in a variety of shades, almost sometimes a copper color also. You know, people have different skin colors. Now, Josh, let me ask you this. Do you know what accounts for what color of melanin you make? Do you know?
Sunlight exposure maybe?
Okay. It's part of it's determined by sun exposure, right? Because we can get darker if we're exposed to more UV, right? But let me ask you this. Do you think if I sunbathed a lot, I could get black? Okay. So what's the other big determining factor?
Genetic?
Big one is this. Is genetics, right? Now, I have filled out different applications in my life for different things, and one of the things they sometimes ask is what race you are. And, you know, Caucasian, or sometimes they'll have white. Now, I'm not truly white. If you go back to the paper here, John, this paper is white that I'm writing on. If you look, this is my hand. I'm not white. There's a big color difference between the white paper and this supposedly white guy's hand. And what happens here is this, is that genetics plays a huge role in what type of melanin you make, all right? You know, no matter how much exposure I get to the sun, I will not be dark black, okay? My genetics also, even though if I don't spend much time in the sun, in the winter here in Minnesota, I'm not going to become truly white. I have a little bit of pigment to myself, and so my skin has this color based on the genetics. And again, it's only, what happens with this is kind of unique is this. Here's your dermis. Here's the dermis here, okay? Here's the stratum basal, SB, stratum basal. And you've got these cells here that are mitotic, one layer of cells. And then once in a while, one of these cells is a melanocyte, okay? Here's the melanocyte here. And I know I've got it in green. But they make these melanin pigments, melanin granules, that color the skin, okay? And sun exposure and genetics is what causes them to produce the melanin, all right? Now, what happens with this, the melanin granules accumulate where there's a lot of sun exposure. And what this does, it helps to provide a shield. The goal with the melanin, one of the reasons we get darker, is that when you get exposed to sun, you increase the amount of melanin that's produced. And that helps to absorb UV. You know, ultraviolet light can cause cancer. And so it's there as a protective mechanism so we don't get, have as high rates of skin cancer as we possibly could. But that's the function of the melanin, all right? It goes up in here, and then what happens is as we go up to the next layer, all right, which we'll go to, but the basal layer is mitotic. It's continually growing, always growing. You will grow skin until the day that you die. If you live to be 105, on your 105th birthday, you'd be making skin cells. It's that mitotic. Once we get past the basal layer, the next layer up, the next stratum or layer, is what's referred to as the stratum spinosum. And the stratum spinosum is made up of several layers, and we'll end with this one today, of cells which we call keratinocytes. Keratinocytes. And this layer is also living and mitotic. Okay, it's still alive, still dividing, because it's close to the dermis. All right, but that's what's referred to as the stratum spinosum. Okay, the stratum spinosum. All right. Now, about out of time for today. What we're going to do, everybody, I told you at the end of today's lecture, yesterday I told you today at the end of the online lecture, I'd tell you when the next test will be. And if you take a look at our handout, okay, at our syllabus, excuse me, what we're going to do is this. Our next test is scheduled for October 8th. What I'm going to do is I'm going to change that to the 11th. So we will take exam 2 on October 11th. All right, we will not be taking it on Monday the 8th. We will wait till the 11th. All right, so I just want to make that note. Again, I want to thank you for tuning in to our online lecture. I hope you're having a good experience. Keep studying, and we'll see you on Thursday for class. Have a great rest of the day. Bye-bye.